This is the lecture for lesson 2. The first part of this lecture will talk about absolute value equations. So we'll discuss what an absolute value is and then how to evaluate it, and algebraic expressions that also have absolute values in them. Before we can do any problems, we need to discuss what an absolute value is. So absolute value is these little bars around numbers. And what it is asking is it's asking how far is this number from 0? And anytime we talk about distance, we're always going to talk about a positive value. So if I ask you, how far is 10 from 0? You would say it is 10 away. If I asked you, how far is negative 10 from 0? You would say 10 units. You don't say negative 10, you just say 10 units. So what happens here is if I have the absolute value of 10, it's 10. The absolute value of negative 10 is 10. Now, I can do this though. If I put the opposite of the absolute value of 10, well, the opposite's outside. So that opposite value is going to come down. And then the absolute value of 10 is 10. So the opposite of the absolute value of 10 is negative 10. So you need to be able to figure these out here. Are these true or false statements? Is the absolute value of negative 12 equal to negative 12? And the answer would be no, that is false. The absolute value of negative 12 is 12 because negative 12 is 12 units from 0. We don't have to say it's negative 12 units, it's just 12 units away. Distance is always referred to as positives. So let's try these. The absolute value of negative 11 is going to give me 11. This one has a negative on the outside, so the negative is going to carry down, and then the absolute value of negative 11 is 11. So these are not equal. So we want to fill in with less than or greater than. Well, 11 is bigger than negative 11, so I would use a greater than symbol here. Next one has a negative outside the absolute value. So a negative outside carries down. The absolute value of 17 is 17. And the absolute value of negative 17 is 17. So this one says negative 17 and 17. Well, negative 17 is smaller than 17. So we'll fill in with a less than. All right, and the last one here, the absolute value of negative 23 is 23. The absolute value of 23 is 23, and these values are equal. And just like before, we can have variables inside here and plug in for them. So it says evaluate the absolute value of 6g minus 3h plus 2. Given g is negative 4 and h is 5. So 6 times negative 4 minus 3 times 5 in the absolute value bars. And then I want to add 2. All right, so let's do the multiplication here. 6 times negative 24, or sorry, 6 times negative 4 is negative 24. And 3 times 5 is 15. So carry that. So negative 24 minus 15 in the absolute value bars, and then I want to add 2. Well, negative 24 minus 15, I need to combine those together. It gives me the absolute value of negative 39. And I then need to add 2 to that. Well, the absolute value of negative 39 is 39. So add 2. And 41 is the answer for the first one. Next wants us to do the absolute value of 4g plus 7h, and then subtract 8 when g is 3 and h is negative 9. So 4 times 3 plus 7 times negative 9, and then minus 8 at the end. So again, I'm going to do those multiplication pieces first. So 4 times 3 is 12. 7 times negative 9 is negative 63. And I'm going to treat this like parentheses. I need to do this work first. So 12 minus 63 is going to leave me with negative 51 in the absolute value bars. And then I need to subtract 8 from that value. Well, the absolute value of negative 51 is positive 51. And I want to subtract 8. And I'm going to get an answer of 43. The last one here wants us to do 5 minus the absolute value of 9g minus 2h. G is negative 2, so 9 times negative 2 minus 2 times h is 9. So I'm going to keep the 5 and the minus and do the multiplication here. 9 times negative 2 is negative 18. Minus 2 times 9 is 18. Negative 18 minus 18 is negative 36. The absolute value of negative 36 is 36, but I want to do 5 minus that answer. So 5 minus 36 is negative 31. The next portion of this lesson is going to be talking about exponents, the product, quotient, and power rules of exponents. So remembering what exponents mean, if we have, let's say, 3 to the third power, that means we're going to take 3 times itself 3 times. 3 times 3 times 3. If we have 7 to the fourth power, that means 7 is multiplied by itself 4 times. So 7 times 7 times 7 times 7. So the exponent tells us how many times that number is multiplied by itself. So in the rule like this, a product rule, let's say we have 3 to the third, and then we want to times by 3 to the fourth. Well, 3 to the third means I'm going to have 3 3s, and then I'm going to add 4 more 3s for a total of 7 3s, or 3 to the 7th. So when you are multiplying like bases, you add the exponents. So when you multiply like bases, we add the exponents. So for division, if we read that here, when dividing exponential expressions with the same base, we're now going to subtract the exponents. So if I have 7 to the 5th over 7 squared, well, let's think about that. That's 1, 2, 3, 4, 5 sevens on top and 2 sevens on bottom. Well, 2 of them are going to cancel out, and I'm left with 3 on top, which is 5 minus 2. Last one here is the power rule. So when you have a power raised to another power, we're going to multiply those. So let's see how that works. So if I have 2 to the third power, and I want to raise that to the third power, well, that means I want to write 2 to the third 3 times. So 2 to the third, 2 to the third, times 2 to the third times 2 to the third. Using that rule up here, that would be 2 to the 9th. Well, 9 is the same as 3 times 3. So these are some rules we're going to use when simplifying. First set of problems here asks us to write 4x squared without exponents. Now, the 4 does not have an exponent, so it only happens once. The x is what is squared, which means that x gets written twice. What is b to the 6th without exponents? Well, that means 6 b's written next to each other. 1, 2, 3, 4, 5, 6. And then we can also work the backwards way, take the multiplication part and put it back in exponent form. So I have 1, 2, 3, 4 threes. So that is 3 to the 4th power. Next set is going to have us use the product rule for exponents. So we're going to be using some multiplication here. So we have b to the 5th times b to the 9th. So that means I'm going to have 5b's written out and another 9b is written out. So as long as it's the same base, we add the exponents. So the base is still b. I have 5, to which I add 9 more, 14. Now, once I throw some numbers in here, it says we're multiplying. So we do still need to multiply the numbers. So let's take a look here. I'm going to rewrite this as negative 1 x to the 4th times negative 4x to the 5th, so that I can see my number pieces. So I'm going to do negative 1 times negative 4. Negative 1 times negative 4 gives me 4. And then I'm going to work with my x's. So I have 4x's here. I want to multiply x to the 5th. So when we multiply, we keep the base the same and add the exponents. So 4 plus 5 is 9. So negative x to the 4th times negative 4x to the 5th gives me positive 4x to the 9th. Last one here, negative 4y to the 8th times negative 8y to the 4th. So let's do the numbers first. Negative 4 times negative 8 is positive 32. So let's work with the y's. I have 8 of them here, and I'm going to add 4 more to them for a total of 12. The next set here is dividing using exponent rules. So the numbers, if we have numbers, we divide the numbers. If we're working with exponents, we keep the base the same and we subtract the exponents. So in this first one, I have 25 x's on top and I have 5 of them on bottom. So the other question you can ask yourself is, where are there more? Well, there's more on top. How many more are on top? 20. So that's how I do it. I say, where are there more? And then how many more? So where tells you if it's going to go on top or bottom. And then how many is going to give you your exponents. So let's not worry about the numbers here. 18 over 3. Where are there more x's? Well, I have x to the 12th and x to the 4th. So there's more up top here. I have 12 on top, 4 on bottom. So that means there are 8 more on top. Now, I do still need to simplify this, though. This is saying 18 divided by 3, which I can do. 18 divided by 3 is 6, x to the 8th. All right, so let's work with this last one here. We have 2 variables, so I'm going to do each one separately. So I'm going to look at the a's. I have a single a on top because there's no exponent next to it. That means it's an invisible 1. And I have a to the 7th on bottom. So that means there are more a's on bottom. So my a is going to go on bottom. And then you ask yourself, well, how many more? Well, if there's 1 on top and 7 on bottom, that's 6 more on bottom. Now I'm going to do the same with the b's. So I have 6 b's on top, b to the 5th on bottom. There are more b's up top. 6 is 1 bigger than 5. So final answer is b over a to the 6th. You can leave the b to the 1 or just write it as b. It doesn't matter. And then this last part here is the power rule. Power rule here means we take multiply the powers here. So x squared, the way I like to do it, I like to always write it out. X squared makes x to the 6th. Next one, 2b to the 6th has to be written 4 times. So 2b to the 6th, 2b to the 6th, 2b to the 6th, 2b to the 6th. And then I multiply it out. So 2 times 2 times 2 times 2, 16. B is going to be 6 plus 6 plus 6 plus 6, 24. Okay, the other way to think about this is this power has to go into both pieces. So this is 2 to the 4th. And then when you raise a power to a power, you multiply the powers. B to the 24th. So it's preference as to how you want to do it. All right, last one for this. If we have negative y to the 4th raised to the 8th power. So that's negative 1. So I'm going to follow this process here. Negative 1 has to go to the 8th power. And then y to the 4th has to go to the 8th power. So negative 1 to the 8th power is positive 1. And then when you raise a power to a power, you multiply powers. So y to the 32. The last set of problems we're going to work with in this lesson are negative exponents. So we will see some negative exponents and then continuing to work with those product and quotient rules and working with powers of those products and quotients. So these rules here are the zero exponent rule and the negative exponent rule. Any number raised to the power 0 gives the answer of 1. So 1 to the 0 is 1. 10 to the 0 is 1. X to the 0 is 1. So any number raised to the 0 power is 1. Now in math, we do not like negative exponents. So what we do is we can move that negative exponent across the fraction bar and it becomes a positive exponent. So if I have currently a 2 to the negative 2 on top, I can move that to the bottom and it will become 2 to the positive 2 power. And vice versa, if I have a 3 to the negative 2 power in the denominator, I can move that to the top and it will become 3 squared. So some quick examples here. If I want to take negative 5 to the 0 power, answer is going to be 1. Next one, I have 1 over 3 x to the negative 2 power. Now we need to be careful because the only piece with the negative exponent is the x. A 1 does not have an exponent. The 3 does not have an exponent. So the negative exponent piece is going to move. We need to move it up to the top so that we can give it a positive exponent. So 1x squared over 3 would be the correct mathematical way to write that answer. And this one here, see? 2 to the negative 4th is over 3 to the negative 2. So I have two negative exponents. I need to flip their spots. So 3 is going to go on top and become 3 squared. 2 is going to go on bottom and become 2 to the 4th. And then I can do those. 3 squared is 9, and 2 to the 4th is 16. Okay, so in these, we have to, again, make sure we have more than one piece raised to a power. They all get raised to that power. So we have the quantity 2x that has to be raised to the 5th power. So that means the 2 needs to be raised to the 5th, and the x needs to be raised to the 5th power. And any number part, we always have to make sure we do finish that. So 2 to the 5th power, if you wanted to type that in a calculator, is going to give you 32. And then we'll have x to the 5th. All right, next, I have negative x squared is going to be raised to the 4th. And actually, if you want to think about it separately, you could think about that as negative 1 raised to the 4th, or you can combine them here. And then y is also going to be raised to the 4th. So the trick is, anytime you take a negative number to an even power, those negatives cancel out, right? Negative times a negative makes a positive. But if I do 3 negatives, then it goes back to negative. But if I do 4 negatives, then it goes back to positive. So every two negatives makes a positive. So if you're ever working with a negative number here and you're raising it to an even power, you can know it's going to end up positive. Okay, so positive. X squared to the fourth, so power to a power means I'm going to multiply powers. So X is going to go to the eighth and Y is going to go to the fourth. All right, so next one here, I'm going to take negative X to the negative fourth and raise it to the negative third. And I'm going to take Y to the negative third and raise it to the negative third. I always like to do it in two pieces here, break all the pieces apart so that I don't miss something. Now, the negative is to an odd power now, so it's going to stay negative. So it's going to stay negative. And when you do a power to a power, you're going to multiply your powers. So negative 4 times negative 3 is positive 12. So I have negative x to the 12th. And if I do the y's here, power to a power, multiply powers. Negative 3 times negative 3 is 9. So final answer is negative x to the 12th, y to the 9th. The same thing is going to apply if you have a division with exponents, multiple pieces. So what I have to do here is I'm going to take x to the fourth and square it and put it over 6 squared. So I'm going to break that power 2 to both pieces. When you raise a power to a power, you multiply powers. So x to the 8th is going to be over 36 because 6 squared is 36. For B, x to the 5th over y to the 3rd is all raised to the 6th power. So I'm going to break them up first. X to the 5th to the 6th over y to the 3rd to the 6th. So power to a power means I multiply powers. So 5 times 6 is 30. 3 times 6 is 18. So I have x to the 30th over y to the 18th. Last one here, x to the 4th over y to the negative 2, all has to be raised to the 3rd power. So x to the 4th raised to the 3rd, y to the negative 2 raised to the 3rd. So power to a power, multiply them together. 4 times 3 is 12. So x to the 12th. And then on bottom, negative 2 times 3 is negative 6. Now I'm not done because we mentioned we don't like negative exponents. So this piece is negative. It's going to come up to the top. So x to the 12th is going to stay where it is. The y is now going to join it so that instead of a negative exponent, we now have a positive exponent. Combining it all together here, let's write all our answers with positive exponents. So 4a is times by negative 2a to the negative 5th. So I'll always do my numbers first. It's telling me to do 4 times negative 2. So 4 times negative 2, and then I have a times a to the negative 5th. Well, 4 times negative 2 is negative 8. And then if I multiply like bases, I add the exponents. So 1 plus negative 5 is negative 4. Uh-oh, I have a negative exponent though. So only the negative exponent moves. Do not move that negative 8. Negative 8 is a number. It's not an exponent. So a to the negative 4th is going to move. And if I move it to the bottom, it then becomes a positive exponent. Okay. Next one, I'm going to go piece by piece. So 72 divided by 9 is 8. And the larger number was on top, so my answer is going to go on top. So now I'm going to work with A's. I have 5 A's on top, 1 A on bottom. There are more A's on top, and that is 4 A's compared to 1 A. So 5 minus 1 leaves 4 additional on top. And then the last one here, B's. I have 11 B's on top and 17 B's on bottom, so there are more B's on bottom. And the difference between them is 6. There are 6 more on bottom. And the last one here, x to the 4th times x to the negative 10th. Like bases, add exponents. So if I add 4 and negative 10, that gives me negative 6. But I can't leave it like that. So what I have to do is it's currently on the top. I need to move it underneath. And I'm going to put a 1 as a placeholder so that I can now have a positive exponent. All right, that is the end of lesson 2. And you can go ahead and work on the homework for this section.